Lesson 41 is about the reciprocal trig functions. The reciprocal trig functions are exactly like any other reciprocal. The reciprocal of 7 would be 1 over 7. The reciprocal of cosine is 1 over cosine. We call the reciprocal of cosine the secant of x, and we abbreviate it SEC. The reciprocal of sine is 1 over sine. We call the reciprocal of sine cosecant x, and we abbreviate it CSC. The reciprocal of tangent is 1 over tangent, and we call this cotangent, and abbreviate that COT. Since the cosine of x equals the adjacent side over the hypotenuse, the secant of x will equal the hypotenuse over the adjacent side. We're flipping numerator and denominator just like we do for any other reciprocal. Sine x is defined as the opposite side over the hypotenuse of a right triangle. Cosecant is therefore the hypotenuse length over the opposite side length. Tangent x is defined as the opposite side over the adjacent. Therefore, cotangent is adjacent over opposite. Okay, now we're asked to find the secant of 330 degrees and the cotangent of 480 degrees. The secant of 330 degrees, well, that's an angle that's located here in the fourth quadrant. Secant is the reciprocal of sine, so we have to find the related angle for this. Our right triangle, remember our right angle is right there on the positive x-axis, and the related angle, or the reference angle, is a 30-degree angle. We know that opposite the 30-degree angle, the length of the side is 1, and because it's down, the y value is negative in this region, our 1 is a negative 1. This angle would be a 60-degree angle, and the side opposite the 60 is root 3. The hypotenuse length in the 30, 60 degree, 90 right triangle is 2. Okay, well, we want secant. Secant is the reciprocal of cosine, so it's going to be hypotenuse over adjacent. So it's going to be 2 over root 3. This angle is a positively rotated angle also. We want the cotangent of 480 degrees. We have to go off to the side and see what this angle is going to be. It's gone around more than once. It's made a full revolution of 360 degrees, and then it's gone to 120 degrees. That angle is located in the second quadrant. And there's the hypotenuse. Here's our opposite side, right angle to the x-axis always. The related or reference angle here is going to be 160 degrees. In this quadrant, it's always 180 minus the actual rotation that equals the related angle. This from here to here is the actual rotation, and that's 120 degrees. So I know that this opposite side here is going to be root 3. The adjacent side is going to be negative 1 because this point is to the left of the y-axis. So therefore along the x-axis it's a negative. The hypotenuse length is 2. So we want cotangent of that. Tangent is opposite over adjacent, so cotangent is adjacent over opposite. They both have exactly the same denominators, so I'm not going to bother to rationalize until I've subtracted. And then when I subtract, I rationalize the denominator. Root 3 over root 3 multiplying by 1 in that form, and that will give me a 3 in the numerator and a root 3 in the numerator and a 3 in the denominator. Okay, the next problem, we have a problem in radians. Now I want you to remember that pi always equals 180 degrees. And therefore pi over 4 is going to equal 180 divided by 4, or 45 degrees. If we multiply this by -3, we get a -135-degree angle. This has been negatively rotated, which means that the vector's gone down, and it's gone down 90 and then 45 more and landed right there in the third quadrant. The related angle is 45 degrees. The right angle, of course, is here, and this other angle in the triangle is also 45. 45, 45, 90 has sides of 1, and because it's to the left, it's a negative. 1, because it's down, it's a negative, and root 2. So the cosecant of this, cosecant is the reciprocal of sine, is root 2 over the opposite side, which is -1. Hypotenuse over opposite. So I would have 2/3 times -√2 over 1. The secant of 11 pi over 4, well again, here's that pi over 4 angle, and we know that it's a 45, so I'm just going to go down here and multiply it by 11, and I will get an angle of -495. Again, that's gone around more than once, so I'm going to subtract it 360 from the absolute value of -495. So that would give me a +495, taking the absolute value. And again, I get a -135 angle for this. This is where it has landed. It's gone in a negative direction once and then gone 135 more. So it's in exactly the same quadrant. The triangle is going to be exactly the same. Our related angle is 45, and the other angle is 45, and the hypotenuse is root 2. I want the secant now. The secant is going to be root 2, the length of the hypotenuse, over -1, the length of the adjacent. And it's going to be minus -√2 over 1 then. Okay, so we have 2, -2/3 root 2, and we have positive root 2 over 1. We want to get a common denominator here, so I'm going to multiply by 3 over 3, and that's going to give me -2 root 2 over 3 plus 3 root 2 over 3. So it's going to give me 1 root 3 over 3, and that will be our answer, just positive root 3 over 3. This one, this example, pi over 3, since pi equals, remember, 180 degrees, pi over 3 will equal 180 divided by 3, and that's going to be equal to 60. And 10 times 60 degrees is 600. Again, more than 300 degrees. This angle's gone around once, a full 300, and we have to subtract 360. We have to subtract 360 from 600, and we find that it's landed in the third quadrant at 240 degrees. Here, 180 plus the related angle equals that 240, so the related angle is going to be equal to 60. The opposite side will be -√3, the adjacent side will be -1, and the hypotenuse root 2. Secant is the reciprocal of cosine, so it's not root 2, sorry, it's 2. And we have then 2 over -1, or -2. Pi over 2, I think everyone can see, is 180 divided by 2, that's 90. So -7 times 90 means this angle has gone a -630 degrees. Again, we use just the absolute value. We subtract 630 minus 360, and we get an angle of 270 degrees. So that's gone down, gone around once, and come to land up here. So it's a quadrantal angle, and we need to remember that all quadrantal angles are defined on the unit circle, the circle that has a radius of 1. We also remember that y is always the opposite side, and the length of the vector, or the radius, in a unit circle is 1. So the sine of this is 1. The cosecant is also 1 because it is the reciprocal of 1 is 1. 1 is its own reciprocal. So our answer here is -2 plus 1, which equals -1. And 5. Another angle in radian measure. Pi over 6 is equal to 30. 30 degrees times 17 is 510 degrees. And we'll subtract 360, and we get an angle of 150. That is located in the second quadrant. The nice thing about radian measure is that you can always tell what the related angle is by finding this pi over 6, and it's 30. We know that opposite the 30-degree angle is 1, positive 1 because it's up, 60 degree, -√3, and the hypotenuse is 2. So our cotangent now, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, so cotangent is adjacent, -√3 over opposite. Pi over 4 is a 45-degree angle. We figured that out in the last problem. And so 9 times pi over 4 is going to be 9 times 45. And 9 times 45 is going to give us 405 degrees. And again, we subtract from 360, and we get 45. This negative is in front of this, so this is actually a -45-degree angle. That means your vector has rotated down first. Related angle, again, always what it is here, pi over 4, 45, -1, 1, and √2. So here we have a √6. It's cosecant, so it's the reciprocal of sine. √2 over -1 is the reciprocal of sine, so it's √6 times -√2. So we have -√3 plus -√12. That doesn't look much like a negative. -√3 minus 2√3. Simplifying this, 4 times 3, 4 is a perfect square. We can take a 2 out. And our final answer then is -√3 times -3√3. And that's it.